Hi, now we will revise on friction and free body diagram. Now a friction is a force that tries to oppose the motion. Whether the object move or does not move, if it's in contact with gas, liquid or solid, alright, there will be frictional force. Alright, so let's look at the 6 example in order to understand friction. Along with it, we'll draw the free body diagram. Now the first example, right, we have a box that rests on a rough surface. Now in this case there will be no friction. Alright, there will be no friction. And if we draw the free body diagram, right, meaning the box only, there will be this force called the weight, which is the gravitational attraction force by the planet, and there will be a force that the surface push upward that we call the normal contact force by the table on the box. So in this case both forces will balance and there is no friction in this case. Now for the second example, if someone pushes the box on a rough surface, alright, someone pushes the box on a rough surface. Now in this case there will be friction because the box is trying to move to the right. Now whether it moves to the right or it remains stationary, but because the pushing force is to the right, the frictional force will exist at this surface here, alright, to the left. Now in this case, if we draw the free body diagram, then again we have the weight, we have the normal contact force. Now the weight is the attraction force by the planet Earth on the box. The normal contact force is the force by the table on the box. And then of course we have this push here. In this example is 2 Newton, and then we have frictional force here. Now if the friction is less than 2 Newton, then no, if the friction is exactly 2 Newton, then the box may not move forward. Right? If the friction is less than 2 Newton, then the box will accelerate to the right. Now let's look at the third example where the box is on a slope. So suppose if we have a box on a slope like this, right? Then in this case, because the box is trying to slide downwards this way, so the frictional force is upward this way. Alright, it tries to oppose the motion. So it may or may not slide down. So if we draw the free body diagram, we have the weight, which is vertical. Then we have the normal contact force that is 90 degrees to the surface. And then we have the frictional force along the surface this way. So this one can be a little bit difficult for some students taking physics. Now whether it slides down or not, it depends on the angle. Alright, if the resultant force of this tree, alright, is 0, then you remain stationary. If the resultant force of this tree is downwards, then it will slide this way down with acceleration. Alright, now let's look at another example. Now if somebody holds a coin, alright, a coin using 2 fingers, alright, this way. So in this case, because the weight is trying to pull downwards. Alright, the free body diagram on this coin will be there is a weight, right, and there is a push, the fingers pressing the coin, and on both sides of the coin there will be friction. Alright, on both sides of the coin, on the surface in contact with the finger, there will be friction. Now let's look at another example. Say if somebody is walking, right, this is the fifth example. Somebody is walking, right? So if it's walking forward this way, this is the ground, this is a shoe, right? If it's trying to walk, say this way, walking forward, alright. Now, if the feet is pushing backward, then in this case the friction will be forward. Alright, the friction will be forward. We are unable to walk on ice because ice does not provide the friction. So if we walk, the friction actually is pushing us forward because the shoe is trying to push backward. Alright, so that is how we walk. Now number 6, the last one, which is a little bit complex. Now if we have a car, okay, we have a motor car, and the motor car is accelerating to the right hand side on the road. Now if these wheels behind are connected to the engine and these wheels are not connected to the engine, alright, so in this case, although both wheels are rotating this way, the car is accelerating to the right. Now the frictional force by the road on the wheel here will be forward, right? Because we do not learn static and dynamic friction, so I can only tell you that the frictional force on the engine wheel is forward, whereas the frictional force on the idle wheel is backward. Alright, so we have completed friction and free body diagram. Thank you for watching.